Earth has roughly 15 to 20% of its habitable lifespan remaining, and while the Sun is only in its middle age, that remaining window is already starting to close. In just over 1 billion years, the Sun will be changing, a shift that will see the habitable zone move outward, and with it, the conditions that have sustained life on Earth for billions of years will begin to unravel. This is not a sudden collapse, but a slow descent, unfolding over billions of years, and in this video we'll follow that arc, from Earth's fading habitability to the brief warming of distant moons, finishing at the solar system's eventual unravelling. And it all begins on Earth. It's often said that Earth has 5 billion years left until the Sun becomes a red giant. But for life on Earth, the end comes much sooner. The Sun is now a stable main-sequence star, fusing hydrogen into helium. As that fuel is gradually consumed, the core contracts and heats up, causing the outer layers to shine more brightly over time. Even small increases in brightness can have large consequences, and in about 400 million years, a 4 to 5% rise in solar output would have occurred, which will push Earth past the inner edge of the habitable zone. The oceans and atmosphere will remain for a time, but the climate stability needed for complex life will begin to break down. In about 1 billion years from now, the Sun will be 10% more luminous than it is today, raising global temperatures by over 30 degrees Celsius. The oceans will begin to evaporate, releasing more water vapour, a powerful greenhouse gas, into the atmosphere, creating a feedback loop that could drive surface temperatures past 100 degrees Celsius, sterilising the planet. With more water vapour reaching the upper atmosphere, solar radiation will break apart its molecules, hydrogen will escape into space, and over time Earth will dry out completely. Its protective atmosphere will also thin and collapse, exposing the surface to lethal radiation, and at this point life, if any remains, will vanish. But this is only the beginning of the transformation. For billions of years, the Sun has balanced fusion pressure against gravity, but around 5 billion years from now, that balance will end. The core will run out of hydrogen, contract and heat up. Hydrogen in the surrounding shell ignites, rapidly fusing and driving energy into the Sun's outer layers. When this happens, the Sun will expand into a red giant, threatening the existence of the planets in the inner solar system. Mercury, closest to the Sun, will be the first to go. Its orbit will be engulfed. Venus follows, its atmosphere stripped, its crust incinerated. By the time the Sun has expanded toward Earth, it may have lost up to 20% of its mass, causing gravity's hold to weaken that may allow Earth's orbit to drift outward. Some models suggest this saves the planet, but others predict that tidal drag from the Sun's extended atmosphere will actually pull Earth inward. Earth's fate is therefore uncertain. It may survive, or it may be consumed. Mars further out will likely escape, but not unchanged. The red giant Sun will emit thousands of times more energy than it does today, with peak luminosity reaching up to 5,000 times its current brightness. Surface temperatures on Mars could rise to 400 or 500 degrees Celsius, turning a frozen world into a furnace. Within this phase, the inner solar system out to at least 1 astronomical unit will be scorched or erased. But even as these worlds vanish, something curious will begin to stir farther out. As the red giant phase nears its end, about 5.5 to 6 billion years from now, the Sun will reach peak luminosity. The energy released at this stage could shift the habitable zone further out, possibly to Jupiter or even Saturn. For the first time, moons such as Enceladus and Europa that have been frozen in darkness may briefly enter a phase where conditions may support liquid water as surface ice begins to thaw. With added solar energy, these subsurface oceans could become more chemically active, potentially enhancing conditions for life. but it's Titan that may undergo the most dramatic shift. Orbiting Saturn at nearly -180 degrees Celsius today, it would warm to 27 degrees Celsius. Methane lakes would evaporate, ammonia water mixtures might appear, and with its dense atmosphere and organic chemistry, Titan could, if only briefly, approach habitability. And for tens of thousands of years, Titan and other distant moons might experience a fleeting spring. But as the Sun begins its final transformation, this warmth will be the last the solar system will ever know. The red giant phase is dramatic but not final. With hydrogen exhausted, the Sun next enters the asymptotic giant branch, a brief but violent period marked by instability. Deep within, helium fusion ignites impulses, unleashing thermal outbursts that throw off massive shells of gas. Through this process, the Sun will shed nearly half its mass in just a few million years. It's a loss that weakens its gravity, and with it, the architecture of the solar system begins to unravel. The outer regions, Pluto, the Kuiper Belt and the distant Oort cloud, feel the effects. The Sun's diminished pull allows many of these objects to drift into new unstable orbits, with some being nudged outward whilst others are lost to interstellar space. It's estimated that as the solar system continues to orbit the galaxy, gravitational tugs from nearby stars will strip away more than 90% of the distant icy bodies in the Oort cloud alone. Even the surviving planets will not remain secure. Over immense timescales, their orbits will slowly shift. Interactions with stars, galactic tides, and resonances may one day eject them. Some might drift into the void, others could collide. Even Earth, if it survives the red giant phase, may eventually become a rogue planet, severed from its star. And at the centre of it all, the Sun prepares for its final transformation. As the Sun expels its outer layers, gases expand into space, forming a planetary nebula, a luminous shell surrounding a fading core. What remains is a white dwarf, a stellar remnant roughly the size of Earth but half the mass of the Sun. This white dwarf no longer fuses elements, it shines faintly, powered only by residual heat. And over 1,000,000 trillion years from now, it will cool completely into what's known as a black dwarf. Cold, dark and undetectable. By then, the solar system will be long gone. No stars will shine in the galaxy. The once mighty Sun, now a silent remnant, will drift alone in a sea of darkness.